This is Geometry, Unit 8, Day 9. We're going to continue talking about central angles. We'll learn about inscribed angles and circumscribed angles. From what we learned in a previous lesson, a central angle is an angle whose vertex is at the center. The measure of the central angle is equal to the measure of its intercepted arc. The intercepted arc is the arc that is formed when the angle touches the edge of the circle. So if the angle here, the central angle, is 80 degrees, then the intercepted arc would also be 80 degrees because they are supposed to be equal in measure. Find the measure of the following angles or arcs in circle E. We know that HF is a diameter. So what I'd suggest is to start out with the figure and find all of the pieces of it and then worry about answering the questions. Here we have our arc, so the central angle is going to be the same measure. On this side we have an arc of 101, so the central angle is the same. Notice that these angles across here are not the same. These are not vertical angles. They're not formed by two straight lines. We have a diameter that's straight here, but these two are bent. So these are not congruent. They're not the same size. But we do have a diameter, so putting together the two angles is going to add up to 180. So 180 minus the 125 is 55. Again, these are not vertical because they're not formed by two straight lines. If this is 101, on this side of the diameter, it's got to add up to 180. So this side would be 79, which would make the arc 79, and on this side the arc is 55. So now we'll be able to take a step back and answer these questions. The measure of FEJ is 125. That's your angle. Letter B, the measure of angle JEH. 55. The measure of arc JFG. JFG is 125 and the 79 put together. Which adds up to 204. The measure of angle GEF. GEF. That would be that central angle at 79. The measure of arc JH, which would be 55. And then the measure of GHJ. GHJ. It's everything minus the 204, or you could add your 101 plus your 55 together. You get 156. Next, we're going to talk about inscribed angles. So this is new for us. An inscribed angle will have its vertex on the circle, and whose sides contain chords of the circle. So over here we notice that the vertex is right on the circle, and the sides of this angle are chords. They have vertices on the circle and they go through. That's different than central angles. Central angles, the sides are radii, but For an inscribed angle, the sides are chords. So the measure of an inscribed angle is half the measure of its intercepted arc. So the angle here opens up and touches AB. So that's called the intercepted arc. The angle is supposed to be half the intercepted arc. So it's half the measure of arc AB. So we can try that. Here we know we have an arc of 100. We're looking for the measure of GHJ. Well, instead of just saying exactly what the angle measure is, it would be great if you would write an equation. So here we have the measure of angle GHJ equals half the measure of the arc. We're following our rule that we learned up here. The angle equals half the arc. So we don't know what the angle is, but we do know what the arc measure is. So we can take half of that arc measure and we'll get 50. So another way to say our formula up here is to say the inscribed angle equals half its arc. Okay, so the angle equals half the arc. That's for an inscribed angle. For a central angle, the angle equals its arc. So you have to pay attention to which angle you're working with. Is the vertex at the center of the circle, or is the vertex at the side of the circle? In this case, it's the side. Here, we're given the measurement of the angle, but we don't know what the arc is. We're going to start out the same way. We'll say the measure of the angle, CBD, that equals half of the arc that is made by that. So we know that the angle is 40. I should put a little m there for the measure of the arc. And the measure of arc CD. Now how can we get CD by itself? So we look at this and we want to get rid of the half. So the way that we can get rid of a half is if we double it. We times it by 2. Essentially that's timesing it by its denominator. So times this side by 2 and you get rid of the half, times this side by 2 and we get 80. Some people say divide by a fraction, which is fine, but mathematically we typically talk about multiplying by a number to get rid of the fraction. So on this picture, we see that 60 is our arc. So when we come down to the inscribed angle, that's going to be half the arc. If we're given the angle, then we know the arc is going to be twice the angle. This is a diameter. So on this top part, it's 180 degrees. It's a semicircle of 180 degrees. So if we take 180 and we subtract the 74, we'll get 106. Same idea here at the bottom. We'll have a semicircle because our diameter, this is the lower part of the circle. So 180 minus 60 is 120. So now we're ready to move over and see if we can answer some of these questions. The measure of angle S. The reason they can use one letter is because at S there's only one angle that's happening. These off here on the side aren't actually angles. If you notice, it's curved. So it's not made by two rays. So angle S is clearly 30 degrees. The measure of arc RQ we determined was 106 degrees. The measure of arc TS is 120 degrees. The measure of arc QS is 74. SQR is half the circle. And the measure of TSQ. TSQ is the 120 plus the 74. Here we're looking at two inscribed angles. We can label one of those to be red. Label another one of those green. So we have two inscribed angles. And those two inscribed angles are opening up to the same arc. It's called the intercepted arc. They have the same intercepted arc, which is over here called AB. So since both angles, inscribed angles, intercept the same arc, we know that those two angles are going to be the same measurement. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So angle ADB, which is the red angle, is going to be congruent to angle ACB because both of those intercept at AB, arc AB. So if we come down to our example number 4, and we can practice this out a little bit. We could look at a red angle. And we notice that that's opening up and touching the 81. So we know that our angle here is going to be half of 81, which is 40.5. We have the other angle that's opening up to touch the same arc. So we know that that inscribed angle is also going to be 40.5. If this is our arc of 81, we know that the central angle is the same thing. Now here we have two diagonals, and they go all the way through the circle. So that makes vertical angles. So here we have 81, and this arc is 81. So for the same reason, here we'd come look at it, and we'd have like this purple angle that's touching there, and also this blue angle they're both intercepting the same arc. So half of 81 again is 40.5. If we have 81 here, then 99 and 81 make 180. So that's 99 on this side. Since those are central angles, we know the arc is going to be the same thing. Now we found out all the different parts of the figure before we try to answer the questions. So the measure of angle SPR, the angle SPR we said was 40.5. The measure of angle PTQ we said was 81. The measure of PTS, 99. The measure of arc PQ is 81. The measure of arc PS, looking at the arc measure, that would be 99. And the measure of SPQ is the 99 and the 81. If this is a diameter, it is the whole part of the circle from one endpoint to the other of the diameter. So that's a semicircle, so we know that that's 180. Next, we're going to talk about circumscribed angles. And those are angles that is outside the circle and the sides are tangent to our circle. So here's a picture. It's an angle. The vertex is outside. And when you open it up, it's touching the circle at a point of tangency. So notice, if two tangents intersect outside a circle, then the measure of their angle is half the difference of the measures of the intercepted arc. So what that means, if you look here, we have an arc on that side. We have a different arc on that side. So when the angle opens up and touches our circle, it breaks the circle into two arcs. Those two arcs are going to be different. The one farthest away is always going to be larger. If this angle is larger, then the process is going to be pretty quick, and we're going to take half the red minus the green. So another way that we could write this is the angle equals half the big arc minus the small arc. The farther this angle is away, the more that your two intersections are going to get closer and closer towards the very top and very bottom. Otherwise, this is not touching the top and bottom of the diameter. What would touch PR would not also be touching the center. So we'll come on down to letter A, and we notice we have an arc that's being formed by the angles. The two arcs put together make 360. So if you take 360 and subtract a 138 from that, you know you're going to get 222. So 222 is that arc. Now we're going to say that the measure of angle T equals half the big arc, which is the measure of PQR, minus the smaller arc, which is the measure of arc PR. So the measure of angle T equals half of 222 minus 138. So we're going to take half. When we subtract these, we get 84. So half of that value is 42. It's very important that you write out the equation so you can plug in your numbers and continue your calculations correctly. If you're just trying to do it in your head and you say that you're using your calculator, sometimes people forget to complete all of the different operations. Okay, let's look on this side. Here they've labeled the bigger of the arcs. But 360 minus 232, that's going to add up to 128. So that makes this part of the arc 128. So we'll call this angle T. So the measure of angle T equals half the big arc, which is the measure of PQR, minus the small arc, the measure of PR. Okay, so now we're going to plug in our numbers. The measure of angle T equals half. The measure of our arc, PQR, is 232 minus 128. That's going to leave us with the measure of angle T equaling half of 104. Then when we take half of that, so remember, when we're trying to figure out the circumscribed angle, it always equals half the big arc minus the small arc. The big and small arc always add up to 360. The red and the green always add up to 360.